Hello again everyone, welcome back to ptet.chemistry channel. So my name is Dr. On, and in this tutorial video I'll be conducting another thermometric titration. This is basically a reaction between an acid and an alkali, an acid and a base, which is an exothermic reaction. Neutralization, the combination of H plus from the acid and the OH minus from the base, they are just coming together and giving you the H2O molecule. So H plus OH minus equals give you H2O molecule. They just come together without breaking any covalent bond at all. You're just forming bonds, bond formations without any bond breaking. Bond formation is exothermic, neutralization is exothermic. In this question that we have this P, which is hydrochloric acid, and we have Q, which is sodium hydroxide. So we put P in the pipette. We put P in the burette. So the hydrochloric acid is in the burette. So I have a hydrochloric acid, colorless obviously, and then sodium hydroxide, which is colorless as well. So this is a burette, so B-U-R-E-T-T-E. It's got a tab, it's got a stop at the bottom. So before I use my pipette and the burette, I have to wash them. So what I have is P in the burette. So I gotta wash with some distilled water first. So I hope this one is clear. What I'm gonna do, just rinse it with some water. So when rinsing, you need to make sure that the thing flows down to the bottom. So that was just rinsing the thing with water. I need to make sure now P is in the burette. P is the hydrochloric acid. So this is the hydrochloric acid. This one goes to the burette. So the first thing I do is rinsing. It's just rinsing, so I have a little bit of the solution in there. I open the tap, and then I rinse. And I open the tap to remove the washings, the rinsing. And then I'm ready to fill in my burette. When I fill my burette for the first time, this thing at the bottom just now, after we rinse, it's already clear. So we need to make sure that we pass through some of the solutions such that they completely fill the bottom bit, and we will be measuring accurate volume later on. So let's continue filling this in. I'm just going to measure it up to 0.0, so there's one decimal place there. Okay, so hopefully you can see this against the white tongue. So that is reading below the meniscus. There's 0.0 cm cube there. Let me just lift this up a little bit so that we are reading below the meniscus, 0.0 cm cube there, because one decimal place reading for the burette volume is to one decimal place in O level, IGCSE level chemistry. So I'm just going to leave the burette there in the meantime. Put P in the burette, which I already did. And I'm going to measure, I use this to measure up 10 cm cube of P into a plastic cup. So this styrofoam cup, S-T-Y-R-O-F-O-A-M, this kind of soft plastic. So this is an insulator, it does not conduct heat. So by doing this kind of experiment which involves heat change using a plastic or a styrofoam cup, we will ensure that minimal heat change or minimal heat loss is actually happening in these experiments. These are actually pretty unstable, so we support it on top of the beaker. So when you draw a diagram, usually it's a styrofoam cup supported inside a beaker. This is a thermometer. Thermometer measures temperature. We use this to measure the initial temperature, the final temperature of the solution, such that we can calculate temperature change. We don't measure temperature change, we measure initial and final temperature. We calculate temperature change. By having the plastic cup inside a beaker, it allows it to sit still when I just hold it on the table. I just put it on the table. So what I have here is just my measuring, well, not my measuring cylinder, but my burette. So I started from 0.0 just now, 0.0 on top of the burette just now. This thing is already filled at the bottom. Put P into the burette, which I already did. Use it to measure 10.0 cm cube of P. So starting from the 0.0, I'm going to pass out 10.0. So I will let it flow full speed until I'm close to 9 cm cube. Then I slow down. I slow down because burette is an accurate apparatus to one decimal place. I do it drop by drop until I get 10.0 cm cube. Okay, so hopefully now I get to show you that this is actually 10.0 cm cube there. So reading below the meniscus, I started from 0.0, now it's 10.0 cm cube. I already passed 10.0 cm cube from the burette. There was hydrochloric acid in the burette going into the plastic cup. Do not try and pass all 10 cm cube with full speed. You want to be accurate, therefore you have to try and do it drop by drop. When you're close to the 10.0 mark, you need to do it drop by drop so that you are accurate and you are not going to risk overshooting the 10.0 cm cube mark. What else are we going to do? We measure the temperature of P to the nearest 0.5 degrees Celsius. That's typical. So we record the temperature to something 0.0 or something 0.5. So I'm going to put my thermometer, the bulb of the thermometer is there, I'm going to leave it in there, and then just leave it in there. Do not read it straight away because temperature of the surroundings might not necessarily mimic or reflect the temperature of the solution. You need some time for the temperature of the solution to be recorded by the thermometer accurately. So leave it for a minute or so. In the meantime, using a measuring cylinder, measure out 40 cm cube of Q. I think I've chosen the wrong measuring cylinder. I've used a 25 cm cube, so I'm just going to stop this for a bit while I go and rush and get a 50 ml cm cube measuring cylinder. Anyway, again, I'm back. So this now is a 100 ml 100 cm cube measuring cylinder. Measuring cylinder measures volume of solution. It's always going to be less accurate than a burette. So a burette is always going to be more accurate. Whatever you measure a measuring cylinder can be improved in accuracy by using a burette to measure the volume instead. So now that I have my measuring cylinder, measure out 40 cm cube of Q as accurately as possible. So I have forgotten something again. They want you to measure out 40 cm cube of Q as accurately as possible. By right, if I do pouring, I will never get as accurate as possible. So what I need to do is I need to do it drop-wise, drop by drop towards the end. So I need something else, which I'm going to go and get right now. It's a plastic dropping pipette. It's a dropper. Okay, I'm back. So this one is a plastic dropping pipette, or we just call it dropper. We do things drop by drop towards the end. It's never going to be accurate like a burette, but at least we can try to be as accurate as possible with the measuring cylinder. So using a measuring cylinder, measure 40 cm cube of Q. Q is the sodium hydroxide, so it's my other solution. Measure 40 cm cube of Q as accurately as possible. So I will pour it until it is close to 40. And then what I do then is I grab the dropper and I use it to add it drop by drop. So what's going to happen? Well, you're not going to see it, I guess, but I'll show you in a little bit. Okay, so what actually that one is now that it is, it's a bit hard with this. So measuring cylinder is never going to be super accurate, but I've tried to be as accurate as possible by doing it drop by drop, by adding the solution Q near the 40 cm cube mark, drop by drop towards the end. Blah blah blah. Pour this 40 cm cube of Q into the plastic cup containing P. I'm supposed to record the temperature of the solution P. That was the hydrochloric acid. This one read as 19.0. Just going to show you on the thermometer. Show you on the screen there. This is against the white tile. So we have 10 at the bottom. We have 20 on top there. It is not focusing that well. Okay, so that is actually reading 19.0. Okay, so I'm holding it at an angle slightly, so parallax error and stuff, but hopefully you can see that better now. So this is 9, this is 10, this is 20, so each of these lines that you can see is 1 degree Celsius graduation. So what we have there reads as 19, but what you record is actually 19.0 degrees Celsius. It's not in between 19 and 20, therefore it's not 19.5, it's 19.0 degrees Celsius. 19.0 degrees Celsius is my starting temperature. So 19.0 degrees Celsius like that. I'm going to mix in the 40 cm cube that I measure using the measuring cylinder from here, and we're going to see what happens. We're going to stir gently with the thermometer so that we distribute the heat, otherwise the heat change is not uniform. And the temperature has risen, it's now around 25. So let's just read it together. So I have swirled it, and let's just read the thermometer together. Not too sure how well that one is showing. So that one is showing you 25.0. So there was 20 at the bottom, 30 on top. From the bottom to the top, that is not in between 24 and 25. That is 25.0 degrees Celsius. Read 25.0 degrees Celsius. So 25.0 minus 19.0, and guess what my calculator showed me? 25.0 minus 19.0. This is my good old calculator. I've had this calculator since 23 years ago. I still really like this model FX992. They have stopped producing it. But anyway, so your calculator show you 25.0 minus 19.0. Your calculator doesn't have that capacity to think your temperature rise is going to be 6.0 degrees Celsius and not 6 degrees Celsius, because your temperature rise was obtained by taking the difference, the highest temperature, because it's exothermic reactions, minus the initial temperature, which must include the nearest 0.5 degrees Celsius precision or accuracy. We're going to do the rest of these experiments now. There are a series of experiments. They're going to take a bit of time, but not as much as in the other thermometric titrations, which you can catch in the other tutorial video. That one took a lot longer because I can foresee here the volume of P is using the burette. That doesn't take very long, but the volume of Q just using measuring cylinder, that should save me quite a lot of time. Let's get started with experiment 2. So what we do with these is we just empty the plastic cup, empty the styrofoam cup, rinse it with water. And that is tap water. I rinse it with a little bit of distilled water, not a lot, just to do rinsing with distilled water. And now it is empty like that. Again, put it on top of the beaker, and then what do I need to do next? I have started from 0.0 to 10.0 just now. Now they want volume of P to be 15. Well, not that it will read 15 in here, but they want another 15 cm cube of this. So I started my initial volume at 10.0. So 10.0 is my initial volume. I want 15.0 cm cube to pass through. So 10.0 plus 15.0. I will stop at 25.0 because 25.0 minus 10.0 is 15.0 cm cube there. They want me to pass 15 cm cube of P into the plastic cup. So I have my plastic cup, the styrofoam cup. So I start from 10.0, I want 15 cm cube, 10.0 plus 15.0, that will give me 25.0. I go fast until I reach around 24, then I will slow down. I will slow down and do drop by drop when I'm close to 25. So I'm close to it. I'm just going to do drop by drop now. Okay, so that reads 25.0 degrees Celsius. Oh, sorry, not degrees Celsius, but 25.0 cm cube. So just below the meniscus there, I started from 10.0. So 25.0 final volume minus 10.0 initial volume. That's going to be 15.0 cm cube of this solution here in here. Okay. Anyway, I'm going to put my thermometer in there, and now they want me to measure 35 cm cube of Q. So 35 cm cube of Q there. That is the next thing. Just now I used 40, so now I'm going to use 35 cm cube. So again, I will go fast and I will slow down when it's close to 35, then do it drop by drop to be accurate. So this is a dropper, and what we do really is, let me just show you what I'm doing. I think I'm just 1 or 2 drop behind. By right, it should be on a level ground, but hopefully you can see what I'm trying to do here. Read below the meniscus, so drop by drop. Well, I mean, measuring cylinder is never going to be accurate. It's not going to be as accurate as a burette, but this is probably the best we can do. Just try and do it drop by drop towards the end. 35 cm cube then. Read the initial temperature. Do not assume that the initial temperature is always the same. I've let the thermometer sit in there for some time while I measure out the other solutions. This one is reading 20.5, so it's slightly different from before. So I can show it to you. Yeah, this is against a white tile, so it's a lot easier to see than in the other tutorial video. Where am I? So that one is 20. So that thing is just above 20. It's in between 20. Actually, I think it's dropped down a bit further. It's 20.0 degrees Celsius now. 20.0 degrees Celsius. So read there, 20.0 degrees Celsius there. Is it 20.0 degrees Celsius? Yeah, 20.0 degrees Celsius. I better write it down first. So record your initial temperature, 20.0 degrees Celsius. I'm gonna put this in here now. Stir, 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 and then I'm gonna record the temperature rise. So what do I have here? Hopefully it's focusing well. Not too sure if it's focusing well. So you can see the temperature has risen. So that is 25, 26, 26, 27. I think in between 26 and 27. I reckon that is actually 27.0 degrees Celsius. But let me just read it without reading it off the screen just now. This is indeed 27.0. You saw it just now, 27.0 degrees Celsius. 27.0 minus 20.0. You can do it on your calculator. Your calculator will show you something different. Your calculator will show you 26.0 minus 20.0. Your calculator will show you 6. Of course, you know, you need to do one decimal place, so there's 6.0 degrees Celsius. So not really that different, is it? Okay, never mind. Oh, hang on. No. Your calculator will show you 7.0. What am I talking about? 20.0 to 27.0. Your calculator will show you 7. So that should be by right 7.0 like that. Okay. Anyway, moving on to the next one. So rinse it out. So rinse out your thing, rinse it with water, throw it away, rinse with water. And then what I'm going to do is I'm going to rinse with some distilled water. And that should be good enough. Got some on my hand just to wash it off. Because obviously, you know, the dangers of acid and bases are that they can be corrosive. So you don't want to, you don't want to get it onto your hand. So what you do is you wear a chemical resistant glove. These are not very concentrated, these are quite dilute, so I'm pretty okay. But by right, acids, bases, they are corrosive, so use chemical resistant glove. Your normal glove are not going to protect you against the corrosive nature of acids and also bases. Now what do I need to do? I need to take some out from the burette again. So remember just now, I'm now left with 25 cm cube there. How much do I want now? I want 20.0. So I start from 25, I want 20.0. So 25 cm cube plus 20.0, that is 45.0. So I let it flow full speed. So full speed until I'm close to 45, then I do it drop by drop. So 20.0 plus 25. Sorry, hang on, what was it just now? 25 just now, I started from 25.0, I want 20.0, so that's 45.0. So there's 44 there. I'm just going to slow down when it's reached nearby there. Now I'm going to do it drop by drop in order to try and get exactly. Okay, so I started from 25.0. And now my reading is now 45.0. So 45.0 minus 25.0 is 20.0 cm cube. I passed 20.0 cm cube of this solution into here, and that is what the question intended. Left my thermometer in there to sit for a little bit. I want 20 cm cube from the burette. There was solution P there. And now I need 30 cm cube for this measuring cylinder one, 30 cm cube. So they don't ask you to do drop by drop towards the end, but you know, something that we can try and improve the accuracy. How do you measure exactly 30 cm cube? You try and add it drop by drop when you are close to the 30 cm cube mark. Reading below the meniscus. So that one is just 30 there, 10, 20, 30. Okay, let's read the initial temperature. Initial temperature, what do I read this one as? 21.0. So try and convince you. 21.0. Probably shouldn't waste too much time doing this because, you know, in a practical we need to concern ourselves with speed. So 20 at the bottom there, and this kind of silvery color line there is kind of dropped for a little bit. There's 20.5, isn't it? In between 20.0 and 21.0 is 20.5 there. So that is 20. Yeah, it's kind of difficult to read. That is 20.5 there, indeed. So that is 20.5. Oops. 20.5 degrees Celsius. Now I'm going to add in the other solutions. So acid and base, stir them gently, and now what temperature do I get? It has risen to around 28.5. So you can hopefully see it's around 28.5 now. Let me just make it clear to you. So there's 20, there's 30. So just 2 lines below 30 is 28. This is between 28 and 29. So it was 28.5. I'm directly in the line of air conditioner, so it might have cooled down a little bit, but that was 28.5 degrees Celsius. 28.5, let me just double check. Yes, it is indeed in between 28 and 29. That's 28.5 degrees Celsius. Gotta be careful with glassware. Yeah? So 28.5 minus 20.0. On my calculator, you will get 8 degrees Celsius, but we know better. We know that our calculator doesn't show us when it's 8.0. It just shows us as 8 degrees Celsius. The temperature difference has to follow the precision of the thermometer as well. I'm going to repeat the same thing now. Basically, rinse it out and do it again. So rinse out with water. Rinse the thermometer. I'm going to rinse it with some distilled water as well, even though they don't ask me to. But it shouldn't affect your result that much. Remember, this is now in the burette, it's now down to 45.0. I don't have enough of it. I'm going to top it up with the acid. So topping up. To make my life easy, I'm just going to top it up to 0.0. Yep, so I'm topping it up. I have just topped up the burette up to 0.0 so that I'm going to start my reading from 0.0 because just now I was running low all the way down to 45.0 already. Now how much of this thing in the burette do I need? In experiment 4, I need 25 cm cube of the thing from the burette and 25 cm cube for the other substance. Anyway, don't mix up your stuff. So I start from 0, I need 25. So if I need 25, I slow down only when I reach 24.5 like that, and then I do drop by drop until I get however much I want. So 24 is around there. Let me see. Oops. So I'm gonna do drop by drop now. Okay, so that one is reading 25.0. So I have just passed, why is that reading a bit weird? Okay, I've just passed 25.0 because I started from 0.0 initial volume, now it's reading 25.0 below the meniscus. You read from below the meniscus, yeah? And that is 25.0 of these solutions, which is P, which is the acid in here. Put the thermometer in there. And I need 25 ml of the 25 ml, meaning 25 cm cube of the sodium hydroxide in here. And I'm just going to use a dropper. This is called a dropper or a plastic dropping pipette. And actually, I've got a bit more out already, so I'm just going to remove some. And then I'm trying to get exactly 25. Well, it's not going to be super exact as I mentioned, but as you could see, there was 20, there was 30, this is in between 20 and 30, that's 25 then. Ready to reach the initial temperature. The initial temperature here is 21 degrees Celsius. I think by this stage you can probably take my word for it already. We already read enough temperature reading, so I probably wouldn't show you for the next one out. So let me just move the camera a little bit so that we are reading at the eye level. So that is 20. Where are we actually? So you saw the 20, and this is just above 20. That should be 21 degrees Celsius. let me just confirm it by actually directly looking into it. That is indeed just above the 20.5, so you know it's closer to 21. So it's 21.0, 21.0 initial temperature. Put this in here. We expect a temperature to rise, and now the temperature has shot up to 28. I've already given it a bit of a stir so that you know the heat change is going to be uniform. So hopefully you can see that that is 30. So we are 2 or 3 lines below 30. We are 2 lines below 30. So there's 28.0 degrees Celsius there. Just double check it. Okay. So I think from this point on, you probably can just trust my word for it. 28.0. From 21.0 to 28.0, you can hopefully see that there's a difference. On your calculator, 28.0 minus 21.0, you're going to get 7.0. Well, you're going to get 7 on your calculator, but you need to be a little bit clever and know that temperature rise is also going to be to the nearest 0.5 degrees Celsius, meaning your reading is going to be 0.0 or 0.5 like that. Well, let's just continue with the rest. So this kind of thermometric titration takes some time, so you need to be careful and not run out of time for the actual heat. Yeah? So I rinse this on distilled water, and that should be good enough. Typically, the first few are going to be slow, but once you get the hang of things, should be alright. I have started with 25 ml here. Now I need 30. It's not going to be enough. I need to top it up. I was going to go for 0.0, but I overshot that, so I'm just going to go for 1.0. So here, remember your initial volume doesn't have to start from 0.0 because you know how to read a burette. I start from 1.0 cm cube there, and I want 30 cm cube. So 1.0 plus 30.0 is going to be 31.0. So I'm going to let it flow until I reach 31.0, but I should slow down at 30. Remember, I started from 1.0. So if I started from 1.0 plus 30 cm cube, it's going to be 31.0. So I will stop at 31 in order to get 30 cm cube of the solution in here. But I need to slow down when I reach around just before the volume that I want. So I'm going to do drop by drop now. And you can hopefully see that this is 31.0. So that is 31.0 there. So 31.0 minus 1.0. I have passed 30.0 cm cube in there. Leave my thermometer in there. 30 cm cube of the burette solution, and I need 20 cm cube from the measuring cylinder. So 20 cm cube from here. Nope, there's just slightly above. So now what I need is I just use a plastic dropper in order to give me 10 cm cube. Oh, sorry, in order to give me 20 cm cube exactly. So that thing there is now 20 cm cube. I haven't left it for too long in there, but I think we should be ready to read the temperature. I'm not going to show you on the screen anymore. This one is reading 21.0 degrees Celsius. You can hopefully trust my word for it. So the initial temperature were pretty much similar, but then we've done a couple now, so they do change, but not by a lot. So the temperature has risen. The temperature has risen now to 26.5. This one I'll just show you. So it's 26.5 degrees Celsius now. 25 is between 20 and 30. So it's just below 26. It's between 26 and 27. So that was, well, I read it as 26.5 just now. Not too sure if it's cool. Yeah, it's cooled down a little bit more. I think it's 26.0 because it's not really halfway mark there. So I would say this is 26.0 and not 26.5. So look for the 25 mark. This is 26.0 degrees Celsius. You don't want to leave the thing lying around for too long. So 26.0 minus 21.0, this gives me 5 on the calculator. In reality, it's 5.0. Left with 2 more to do. what I do next is I need 35 cm cube from the burette. I'm only left with 31 there, not enough. I need 35, so I need to top up depending on how much you need. So be very careful and plan ahead. So if I need 35, I think I can start from 10.0. So I'm going to start from 10.0 cm cube there. So that is 10.0 cm cube. I need 35. So 10.0 plus 35 is going to be 45 in there. So, well, I mean, 35 cm cube pass through, 35.0 plus 10.0 is going to give me 45.0. That is when I will stop. So I go full speed, I let it go full speed, and I only slow down just before I reach 45. This is how you use your burette efficiently, effectively. I don't know what you call it really. It's not that fast though. I wish it's faster. We're left with 2 more experiments. So this is the second to last. So okay, I will do it drop by drop now just to get it to 45. And that is reading as 45.0 cm cube now. So let me just leave this out a little bit. I get a bit tiring now. Anyway, so that is 45.0 cm cube. And because I started from 10, so 45.0 minus 10.0, this gives me 35.0 cm cube for the volume of P from the burette 35 cm cube. Having done that, stick a thermometer in there, and we only need 15 cm cube in the measuring cylinder. So I have 10 already. I'm just adding a couple more drops in order to get it up to 15. Okay. So if you keep on pouring in and out, you're going to be wasting a lot of time in the real exam. So use a dropper when you're close to it. So this is in between 10 and 20. There's 15 cm cube there. Let's read the initial temperature. So this one is reading as 21.0 degrees Celsius. So I record as 21.0 degrees Celsius. Stick it in there. And then stir it gently with the thermometer. And then read the temperature. This has gone to 25. I think it is going to be 25. I already swirled it gently just now. Let's see. So hope you can see that that is right in between. No, actually it's not right in between. Okay. Don't have another hand to change the angle of the camera, but this is exactly that in the middle. So this is 25.0 to 1 decimal place. Yeah, 25.0. So 21.0 to 25.0. This is 4.0 degrees Celsius temperature rise. For the last one, so rinse your thermometer in the cup. I personally rinse it with a little bit of distilled water. Again, I don't think it will make too much of a difference here, but it's just what I do. Alright. The next thing is I need 40 cm cube. So I only have 45 now, not enough. I should fill it up all the way to 10. Then 10.0 plus 40.0, that will give me 50.0 as the final volume. Okay, so I've got it to be 10.0 cm cube now. Let me just show it to you on the screen. And that thing there. It is at a bit of an angle, so I better straighten it up. So that is 10.0 cm cube. I want 40.0 cm cube, so I'm going to stop when it reaches 50.0 there. Okay, so 10.0 initial volume. I will stop at 50.0 final volume, and that is when I know I have passed 40.0 into the plastic cup. When I have 40 cm cube of this solution from the burette, there was P, there was hydrochloric acid, then I will add only 10 cm cube of the NaOH from the measuring cylinder. So this is probably going to take a while, but I don't want to take my eye off it. Because you probably only have a chance to do everything one time only. This is not a repeat kind of experiment, but obviously to make your result more reliable, you can repeat the experiment, okay? Not too sure if you can see this, but just give me a moment and I should be able to finish this. Alright, so I've gotten this to be 50.0 now. So I have passed 50.0 minus 10.0. I have altogether passed only 40.0 cm cube of this hydrochloric acid into the plastic cup. So I'll put my thermometer in there so that it will be reading the temperature of that. While doing that, I need 10 cm cube of this sodium hydroxide. So it's not a lot of the sodium hydroxide, I just need to do it using a dropper or a plastic pipette, a plastic dropper. Essentially we are adding dropwise until we get the desired volume in the measuring cylinder, right below the meniscus. So that thing there, right below the meniscus, so 10.0. Again, measuring cylinder is not as accurate as a burette obviously, so it's one of the things you can improve the accuracy is to use a burette to measure out whatever volume or solution you want. So this thing is reading as 20.5. Just show you, since it's probably a second to last temperature reading that I'll get to show you in this tutorial video. So that was 20, that is 20. And where are we? We are in between 20 and 21, and I think the temperature has gone down a little bit more. Let's just do an initial reading again. No, it's still 20.5, it's still 20.5. So there's 20.5 degrees Celsius there. I think I showed you earlier, but anyway, while we can see it against the white tile, why not, eh? So 20, it's actually quite difficult to see against this, okay? So there's 20, the longer line, 20, and then this is in between 20 and 21, so there's 20.5 degrees Celsius. Now I have this solution here, 10 cm cube of it. Put it in there and see what happened to the temperature. So it's gone up to 21 to 23. It's gone up to 23.0. I already swirled it a little bit with the thermometer. So it's gone up to 23. Let me just lift this up a little bit so that we are reading it the right way. So that is 20, 21, 22, 23.0. You're reading from down to up. 20, 30, so 21, 22, 23 degrees Celsius. So 23.0 because to the nearest 0.5 degrees Celsius. So 23.0 minus the 20.5, you are going to get 2.5 degrees Celsius. Am I correct? Yep, so that one is fine. Out of all the temperature rises, you will see that only one of them, your calculator will show you as the 0.5, the rest of them is 0.0, and your calculator will not show you that. Now what is important, however, the next thing is actually to plot a temperature rise against the volume of P on the grid. And you're supposed to get intersecting lines, and that's something that I'll go through when I go through the question paper itself in another tutorial. So what have we done in this practical? So what we have done really is this is thermometric titration. We are trying to get to the end point of neutralization reactions by measuring their temperature changes, and we're going to get temperature change as we change the volume of acids, we change the volume of alkali, and then they're going to intersect when you plot a graph of temperature change, which is temperature rise, because neutralization is exothermic reaction. They release heat to the surrounding. The solution is going to get hotter, so temperature rise against the volume of whichever solution that you add. They're going to intersect. Where they intersect on the x-axis, that's the end point. That is the volume of whatever solution you need in order for them to get neutralized like that. And you can't measure that directly. You don't do it with the indicator. There is no indicator, and therefore there's no color change in this at all. It's just colorless plus colorless, and you're doing a thermometric titration and not an indicator guided kind of titration. Okay, so thank you for watching, and do subscribe to my channel. Use the button, click the button on the bottom right, and follow me at ptet.chemistry. That is at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected. You can check out all my other full paper tutorials as well for the O-level, GCSE, IGCSE level, or the A-level, the IB chemistry level tutorials, either through the topical playlists, which are available for free, or you can also upgrade to a silver tier membership to enjoy the full yearly paper tutorials as much as you want for only the price of a cup of a coffee, and that's just to support my work and to keep the channel going. Thank you for supporting my work, thank you for watching, and I'll see you in the next tutorial video.